Okay, let's move on to problem 129. Okay, you're given a solid that is a mixture of sodium sulfate and potassium sulfate. A 0.205 sample of the mixture is dissolved in the water, and excess of aqueous solution of barium chloride is added. Then it forms barium sulfate. So which means is when we added the barium sulfate, barium chloride into this mixture, it simply just take away the sulfate ions and form barium sulfate. So after the barium sulfate is formed, filtered, dried, and weighed, its mass is 0.298. Okay, what mass is this in a sample? So I think this problem is very easy because we know what is the molar weight of the sulfate ion, and we know what is the molar weight of this barium sulfate. So we can calculate how much mass is the sulfate ion by what? By the composition, right? Okay, so in the first part is easy. 0.298 times by the whole mass is 233.4, and the composition inside is 96.707. And we can finally calculate it. That is 0.123 grams of sulfate ions. Okay, and we know one thing. Oh, okay. The total sulfate ions inside of this mixture is 0.103. So the percentage inside the sample so the composition is what? 0.205 over 0.123, I'm sorry, is 60%. So we finished the first two problems. The first one is 0.123, and this next one is 60%. Okay, so and the next one it asks what are the percent composition by mass of sodium sulfate and potassium sulfate inside of the sample. Okay, so we don't have to focus on the original question from now on because we already have the percentage of the sulfate ion inside this mixture. So let's just basically let our problem become more easily. Okay, let's do this. Let the sample weight 100 grams. Why we do this? Because the final question only asks about the percent composition by mass. Percent composition, percent. We don't have to calculate the real number. So we just use 100 as our convenience, okay? So next, we will have 60 grams of sulfate ions over here. Okay, is that clear enough? So after we have the 60 grams, we have to calculate moles. So we use 60 to divide it by 96.07. In the previous one we have calculated, and we can obtain the number of 0.625. Okay, so if we have 0.625 moles of sulfate ions, what this kind of information can give to us? Okay, so the first one we have to focus on the charge, right? And what? The charge of total. What is it? Okay, you totally have 0.625 moles of sulfate ions, and each sulfate ions of per mole will give -2 of charge. So it will get negative 1.25. Is it? Oh, yes. So we can know one thing about this. Okay, so we want to calculate we want to calculate how much mass are there in we want to calculate how much mass is contributed by the sodium and the potassium ion. So let's let this. The moles of sodium and the moles of potassium is X and Y. Okay, so we know one thing now. Because each sodium and potassium are all have +1 charge. So in this part, we can get 1.25 in the first part. And secondarily, the weight, mass, are what? Are 40. Because we assume the total weight is 100, and we know that the sulfate ion, SO4 ion, will get away 60 grams. So the sodium plus potassium will contribute 40 grams of the weight. So okay, so we know what is happening is. So we can simply just calculate. 40 is the, no, maybe I should not use this. 39.1 is the weight of potassium. So 39 times Y and 22.99 is the weight, molar weight of the sodium. 22.99 times X will equals to 40. Okay, finally, you can solve this problem by using the calculator again, so I will not demonstrate this again. So you can simply calculate it that Y will equals to, let's see, what do we have here? And 0.7, and X will equals to 0.55. So after you finish this kind of calculations, then I think it will be easy to finalize the final one. Okay, mass of Na2SO4, mass of K2SO4. Okay, we set the potassium is Y, so 0.7 times 2 over 1, and times by the weight of the potassium sulfate. Over here, 174.27, and the mass from the sodium sulfate is like 0.55 times by 2 over 1 over 2. Because yeah, I expand this. If you have 2 moles, if you have 2 moles of sodium or 2 moles of potassium, then we can know the total of the sodium sulfate and the potassium sulfate should be divided by 2, because 2 sodium atoms can make up 1 sodium sulfate molecule. Okay, so and then this part we will times by okay, I don't need this. Okay, I think calculated to this point will be enough.